Ladies and gentlemen, good day. My name is Willis Ganzerla. I am PhD student at the University of Campinas. In this symposium, I will present the study entitled Bioenergy Recovery from Dry Anaerobic Digestion of Agroindustrial Wastes. Starting with an introduction about the subject, the food industry in Brazil is a robust industrial sector, responsible to the generation of around 10% of the gross domestic product in 2019, mainly due to the exportation of orange juice, coffee, dairy products, and beer. To produce these products, the industry demands a high amount of energy, which is obtained from non-renewable sources. As byproducts, the industry generates organic and lignocellulosic wastes, which currently are not treated and then are responsible to environmental impacts. Therefore, due to the environmental concerns, it's necessary to correct the management of these byproducts generated in the food industry. The management of organic and lignocellulosic wastes with anaerobic digestion can be an alternative to a sustainable development of the food industry. Since the adoption of an appropriate treatment system, it's possible to recover bioenergy and bioproducts. Regardless of this process, the food industry can avoid the improper disposal of solid residues and then reach the sustainable development goals. Therefore, this study aimed to assess and start up dry anaerobic reactors of açaí seed and brewery spent grain as an alternative for the food industry waste management. For this, the technology was studied and optimized in a laboratory study to provide solutions for bioenergy recovery for the circular economy transition of the food industry. The anaerobic digestion, two reactors were started up, one for brewery spent grain and another for açaí seeds. The reactor operated with 25% of feedstock, the solid residues, 45% of inoculum, and 30% of water. These reactors were from dry type, since contains more than 20% of volatile solids in its initial composition. Both processes were operated at mesophilic temperature and methanogenic pH. Beyond, the process performance was monitored for 22 days in batch mode, and the biomethane potential was recorded. The results demonstrate that the anaerobic digestion can be a good process for the management of byproducts. The reactor presented a stable methane profile, reaching 70% of methane. The reactors operated with burst grain reached a high methane yield when compared with açaí seeds. The biogas production can be submitted to a heat and power unit to generate heat and electricity. The electricity potential was higher for burst grain when compared with açaí seeds, with proportional values for thermal energy. The adoption of anaerobic digestion and bioenergy recovery can avoid greenhouse gas emissions by replacing the electricity from the grid and natural gas from the boilers. Based on the results obtained, we can propose innovative technological roads to the implementation of anaerobic biorefinery in the food industry. Also, the integration between waste treatment and bioenergy production could be a solution to reconcile energy recovery, waste to energy, and environment conservation within the Sustainable Development Goals. In conclusion, it's possible to recover methane-rich biogas and bioenergy from dry anaerobic digestion of agroindustrial wastes, which avoids final disposal of their byproducts in landfills, incinerators, or used animal feeds. Therefore, a novel and eco-friendly destination can be highlighted. Finally, energy recovery from waste can be a strategy to decrease the food industry carbon footprint towards a sustainable transition to a circular economy. Thank you very much for your attention.